What is up? And now we're doing a brand new thing called the areas of circular sectors. And this in celebration of Pi Day, I guess, even though that's really geeky. We're going to find the area in square units of like slices of pizza or pie or whatever. We have this problem all set up for you, and we're going to accomplish two things. First of all, we're going to find the length of the intercepted arc by an angle that equals 2 pi over 3 radians. Now, this is all about the unit circle, and that's the reason we've been studying this, and this will make more sense if you know the unit circle. And then we're going to also find the area of a sector, and I think this will take less than 299 seconds to do the whole thing. So let me show you how this works. 2 pi over 3 radians. If we come over to a different layer that I'm going to make disappear here in a second, so I'm going to write this down. If you're writing this in your notes, do it down here. So 2 pi over 3, if I just want to know how many degrees this is in degrees, I'm going to multiply that by 180 over pi, do a whole bunch of canceling real fast. This 3 and this 180, just follow along here, rewind this if you get stuck. That's going to look like that. And bam, it's 120 degrees. 120 degree angle, which is obtuse, is 2 pi over 3. If I look at it on the unit circle real fast, you can see that 2 pi over 3 is equal to 120 degrees. You guys had a quiz on this yesterday. 2 pi over 3, 120. Let me get rid of that. Bam. And now this is 120 degrees. If I had to, again, draw an angle that looks like that, all right, like that, on this piece of pizza or pie or whatever we're dealing with here today, it's going to be something like this right there. And now what we're going to do is two things. We are going to find the area. I could make that niftier, I apologize. But I'm going to find the area, that green region right there, which is called a sector. And I'm also going to find the arc length, which is going to be called S, of this thing if you cut it from here to here, based on this angle being 2 pi over 3. So this is theta here. This is 2 pi over 3. So to do the math, we're going to go through these two steps. We'll do step 1 first, find the length of the intercepted arc. To do that, you use this equation right here. So to do step 1, that is S equals R times theta. R is radians. Now, don't be tempted to use 120 degrees. You want to use 2 pi over 3. So 2 pi over 3 times, that's going to be theta, times the radius, which is 14 centimeters. I did kind of get those backwards. I apologize for that. Usually it's 14 centimeters times that. But if we hit the buttons all together here, the way that I think you should probably do this is just go 2 times and then pi equals divided by 3 and then times 14. And that sector length, the arc length, S, is going to equal, and correct me if I'm wrong, 29.3. And then would that be centimeters or square centimeters? It would be centimeters because it's a length. Okay, it would be a length. And remember, this would be like cutting this arc out and stretching it out like it was a piece of rope. So you're talking about a length you can measure with a tape measure. Now to do step 2, which is find the area of this sector, or the green shaded in area here, I would have to use, and I'll do this in greenish, this formula, A equals 1/2 R squared theta. Now we don't have any shenanigans of converting theta around because it's already given to us in radians. It's 2 pi over 3. And our radius is given to us as well, 14 centimeters. In the real world, if you were doing something like this, you'd have to kind of, and that's what we'll do tomorrow, but you would have to plug this stuff in here. So this is a half, or 0.5. The radius, still 14, and that's going to be squared, times theta, which is 2 pi over 3. So this is nothing more than taking a simple formula, plugging everything in, and grinding this math out. Again, though, I have seen the best math students take this, go from here and completely blow it and get the wrong answer. So if you're going to hit the buttons here, do 14 squared first. Hit equal, so it's 196. Divide that by 2, and then multiply it by 2 pi, and divide that answer by 3, and you should get area equals 205.1, and that's rounded. And that one, my friends, would be centimeters squared, because that's an area. This is the area of that big piece. It'd be like 2 pieces of pizza or whatever, 2 big pieces. This is how to find the area of a circular sector, and also it reviews how to find the length of the intercepted arc, which is this piece of blue line here called S. All right, guys, I will talk to you later, and we'll apply this tomorrow.